Hello everyone, welcome to today's lecture. In this lecture we are going to discuss about the accuracy and error measures of classifiers. So when we get the data after data cleaning and pre-processing, the first step we do is to feed it to an outstanding model and of course get the output in the probabilities. Yes, but hold on, how we can measure the effectiveness of our models? So better the effectiveness, so we can say that better the performance, and that's exactly what we want. Yes, and it is where the confusion matrix comes into the limelight. So the confusion matrix is a performance measurements for any types of machine learning or any types of classification algorithm. So with that, or with the help of the confusion matrix, we can get the effectiveness of that algorithm. So the confusion matrix is a table that is often used to describe the performance of the classification model. So this figure shows the confusion matrix. In here there are two target variables, which is positive or the negatives, and there are two classes, true class and predicted class. Here true class means the actual value and the predictor class means what the model predicts. Yes, so let's understand each of the term in detail. So here the first term is the true positive. Here TP means true positive. Here let's understand with one example. Suppose I am suffering with some disease and I visit to the doctor, and after checking, doctor says that yes, you are suffering with jaundice. So here doctor provides it's a positive review. So here this is a P, means positive. So predicted class means doctor predicts that it may possible that you are suffering with the jaundice. So that is why here P means positive. Here first is a T, means true. So doctor provided his review that you are suffering with the jaundice. After getting the reports, it is also shows that you are suffering with the jaundice. Your jaundice is a positive. So here both prediction of the doctor and the values in the report both are true. So that is why it becomes true positive. Same as false positive, means doctor says that you are suffering with jaundice. So doctor's review is positive, but report says it's a negative. It means the decision of the doctor is negative, false. That is why we are writing here as a false positive. Here third one is a FN, means false negative. Means doctor says you are not suffering with any disease. So the doctor decision is negative, but report says positive. So here the decision of doctor is not true. That is why false negative. And the fourth one is true negative, means doctor says you are not suffering with the jaundice, and also report says you are not suffering with the jaundice. So this statement will become true. So that is why it become true negative. So I hope this is clear to you that true negative means model has given prediction no and the real actual value was also no. That is a true negative. Second is a true positive. The model has predicted yes and the actual value was also true. Now third one is false negative, means the model has predicted no but the actual value was yes. And the last one is false positive, means the model has predicted yes but the actual value was no. So that are the main parameters of the confusion matrix. Now based on this confusion matrix we can measure the different accuracy measures. So the first one is accuracy. So it gives you the overall accuracy of the model. When we are talking about any classification algorithm, at that time mostly we are using the accuracy as a measure that how effective our model is. So for that we are using the accuracy, and the formula for accuracy is true positive plus true negative divided by total, means true positive plus false positive plus true negative plus false negative, and all that value we can get from this confusion matrix. So these are the derived measures from confusion matrix. Next is a precision. Precision tells us how many of the correctly predicted cases actually turn out to be positive. Yes, if from 100 samples the model says 80 is a positive, so we need to check that if all that 80s are correctly predicted in the correct class or not. So that is from that we can define from precision, and the formula is true positive divided by true positive plus false positive. Next is a recall. So recall tells us how many of the actual positive cases were be able to predict correctly with our model, and the formula is true positive divided by true positive plus false negative. So these are the main measures we can derive from the confusion matrix, and this is a measures with that we can calculate, or we can get the effectiveness of our model. Next one is a error measures. As well as accuracy, we need to find the errors also, that in which samples errors are occurred. So that we can measure using some different measures of errors, and the first one is a mean square error. So mean square error is by far the most common measures of the numerical model performance. It is simply the average of squares of the difference between predicted value and the actual values. It is a reasonable good measure for performance, though it could be argued that it overemphasizes the importance of large errors. Many modeling procedures directly minimize the MSE. So this is the most important measure that is used to find out the errors, and it is simply by calculating the average of squares of difference between predicted and the actual values. Next error is a mean absolute error. So mean absolute error is similar to the mean square error, but here we are not taking the squaring. Yes, but we are using the absolute value instead of squaring. This measure is not as popular as MSE, though its meaning is more intuitive. So this is not mostly used, but mostly for errors we are using the mean square error. Next is a bias. So bias is the average of the difference between the predicted and the actual values. With this measure, positive errors cancel out the negative ones. Bias is intended to assess how much higher or lower predictions are, or on average, than the actual value. So here we can calculate the bias. Also we are providing bias value to the model also to improve the efficiency of the model. So these are the accuracy and error measures of any classification algorithms. Now the next one is evaluation of the accuracy of classifier of the predictor. So when we are building any classification model, and then we are calculating the accuracy of the model, but by only one method, by only taking that one portion of databases, we cannot get the correct output. Yes, so for that there are multiple accuracy evaluation measures are there. Accuracy evaluation methods are holdout methods, random sampling, KFold, cross-validation, and bootstrap methods. So by following any of this method, we can get the more accurate results. So for that we are using this method. The first one is a holdout method. So in this method, the given data is randomly divided into two independent sets, training sets and test sets. Here we need to understand one thing, that for any types of classification algorithm we are using two data set. First is a training data set and second is a test data set. In the training data set we are taking most of the portion in the training sets and a small portion as a test set. Suppose we are taking 75% of data as a training set and 25% of data in a test sets. So typically two-thirds of the data are allocated to the training sets, and the remaining one-third is allocated to the test sets. So here we are using measure data into training. The training set is used to derive the model whose accuracy is estimated with the test sets. So once we are building the model, after that we need to provide training to that model so the model can learn from it. Yes, so for that we are using the training set, and after that to check the efficiency or to evaluate that model we are using the test data sets. So this is a simple method. It is called the holdout method, in which we are providing 2/3 of data into the training and 1/3 into the test data set. The second method is a random sampling. While in the random sampling is a variation of the holdout method, in which the holdout method is repeated k times. The overall accuracy estimate is taken as the average of the accuracies obtained from each iteration. Suppose we are taking 75% of data in the training and 25% of data into the testing. We are repeating this process, suppose 10 times. So result of each iteration is different. So we are taking the average of it and then we'll calculate the final result. So that is a random sampling. Fourth one is a KFold cross validation. It is a very important method to evaluate the accuracy. Yes, mostly in the classification algorithm we are using the KFold cross validation method. In the KFold cross validation method, we are given a data set and we are splitting into the k numbers of sections. Suppose here we are taking the k is equals to 5. It means the data set is split into the 5 folds. So in the first iteration, the first fold is used to the test model and the rest 4 are used to train the model. In the second iteration, the second fold is used as a test data set and all others are used in the training data set. Same as in the third iteration, we are using fold 3 as a test data set and all folds, rest of the folds are in the training data sets and so on. So what is the benefit of it? We are taking a whole data sets in the training. Yes, because in the fold 1, this whole rest of the 4 data set is given as a training to the model. After that, this fold 1 is also given into the training. So each and every fold, so each and every items in the database will be used in the training. So model can easily classify the new data, yes, test data. So the accuracy of the model will be increased. And the last one is a bootstrapping. So technically speaking, the bootstrap sampling method is a resampling method that uses a random sampling with replacement. That is, each time a tuple is selected and it's equally likely to be selected again and read to the training sets. Or instance, imagine a machine that randomly select tuples for our training set in sampling with replacements. The machine is allowed to select the same tuple more than once. So here what happened? This is the initial data set. Yes. Now we are taking some of the data in the this first section, then others into second section, then more others in the third section and so on. Yes, suppose this is the data 1, 2, 3. Now we are applying this data onto the model, same model, in the classification model, and at the end we'll get the accuracy. Suppose it will generate 5%, this will generate 1, this will generate 5. So here after that we are using the majority votes. So here the majority votes is 5. So after that I will combine this and will get the majority as a final result. So at the end we'll get the 5% as a accuracy. So in the bootstrapping method we are dividing our data and by using the sampling with replacement method, and after that we are applying this data to the model and it will generate some result. Now based on the votes, yes, we are taking our final results. So this is how we can evaluate the accuracy of a classifier or the predictor. So that's it. Thank you so much.